So please join. So please tell me, am I audible? Am I audible? Am I audible? Can you see the board clearly? Can you see the board? Okay, thank you. So I think, can I start? Good afternoon, Swarupo. So suppose suppose the inner product space yes, good afternoon, all of you. Only 19 students I see now. Only 19 students are there. So please join. VBA inner product space is a subspace of V, and since this is a subspace has a basis, we take orthogonal basis we take orthogonal basis that is yes, Disha, Anushka, good afternoon. So, so can you see the board? Please tell me if you have any problem. I take first is the inner product space and S is a subspace of V. Then I take x1 x2 xn, which is the orthogonal basis of S, that is scalar product of xi is j. Anyone, yes or no? Good afternoon. Scalar product of xi is equal to 0 for all I not equal to j. Now, if beta curve with any vector Anushka or Hazy, Now tell me, is it fine? Is it fine for you, Anushka? It is not visible. I think it is a yes. Shubhadeep, are you see the board clearly? Tell me. So I think yes, sir. Okay, thank you. So now now if beta curl be any vector which belonging to V, but beta curl does not belonging to S, this implies beta curl x1 curl xn curl is a set of set of independent vector. So are you agree with this statement? If beta curl be any vector which belonging to V but beta curl does not belonging to S, then beta curl x1 curl xn curl is a set of independent vector. Are you agree? Are you agree with this statement? Please tell me. Please tell me. This beta curl x1 curl xn curl is a set of independent vectors. Now, since these are independent, these are orthogonal vectors x1 curl xn curl, then using Rouse-Smith orthogonalization technique, if beta curl only one, see, this is the orthogonal basis x1 x2 xn, hence x1 to xn. If it is, since it is the basis, x1 to xn is a set of independent vectors. If beta curl does not belong to S, beta curl only one, beta curl does not belong to S. This means beta curl cannot be written as a linear combination of the vectors x1 curl, x2 curl, xn curl. That means beta curl, x1 curl, x2 curl, xn curl is a set of linearly independent vector. Here one is one might be. See, since beta curl does not belong to S, beta curl cannot be written as a linear combination of the vectors in a basis of S. Therefore, beta curl along with the basis of S gives a set of independent vector. Clear? Anirban Maiti? Anirban clear? Please tell me. Beta curl does not belong to S. This means beta card cannot be written as a linear combination of the vectors of basis. This means beta curl, x1 curl, x2 curl, xn curl is a set of independent vector. Tell me, Anirban, I am asking you, please tell me, are you agree with my argument or not? Okay, thank you. So, using Brown-Smith optimization technique, beta curve plus sum over Ci xi curve I from 1 to n gives gamma curve where Ci curve such that any vector gamma curve scalar product of gamma curve and xi curve equal to 0 for all I from 1 to n. So this means beta curve, I replace gamma curve by beta curve plus sum over I from 1 to n Ci xi curve, this is equal to 0. So this is equal to since xi's are orthogonal vector, this means sorry, I did some mistake here. This is not correct. Okay, Ci hence gamma curve equal to beta curve minus I from 1 to L beta curve cycle 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 into cycle. I denote this vector by alpha curve. So beta curve equal to minus alpha curve, where alpha curve equal to sum over so you see that gamma curve equal to beta curve minus alpha curve. This implies beta curve equal to gamma curve plus alpha, where alpha curve is a vector which is a linear combination of the basis of S. Hence, alpha curve belonging to S. Clear? So this alpha curve belonging to S and gamma curve is a orthogonal vector of all xi's, x1, x2, xn. That means gamma curve is a vector which is orthogonal to any vector in S. This means gamma curve is orthogonal to S. Clear? Gamma curve is orthogonal vector of any vector in S because gamma curve is a orthogonal vector orthogonal with x1, x2, xn. Since x1, x2, xn is the basis of S, this means gamma curve is orthogonal to any vector in S. This means gamma curve is orthogonal to S. And this beta belonging to V but does not belong to V. So you can write this alpha curve is a orthogonal projection of beta curve, orthogonal projection of beta curve on S and gamma curve is a orthogonal projection of beta curve on orthocomplement space of S. Agree? Tell me. Up to that, you are agree with my argument or not? Tell me. Yes. Anushka say yes. So anybody, if you have a doubt, please tell me. Before going to the next question, please tell me these things are clear or not. Ashwati say yes. Subhajit say yes. Okay. I think things are clear now. Now, Suppose suppose G equal to R. Okay, I take S, which is a subspace of V, as collection of vector where x1 equal to 2x2. Okay, our first find orthogonal projection of vector 1, 1, 1. We see that we can easily check that 1, 1, 1 does not belong into S. Why? If it is belonging to S, then first component equal to 2 into second component. But here this thing is not happening. So 1, 1, 1 does not belong into S, but 1, 1, 1 belonging to V. Clear? Tell me, clear? 1, 1, 1 belonging to V but does not belonging to S. So our job is to find orthogonal projection of this vector where on S. Agree? This is the problem. So for this, first I find the basis of S. So we write this as if this vector belonging to S, then it should be and we write this thing as hence let this as y1 curve, this is y2 curve. So y1 curve, y2 curve forms a basis, is a basis of S. Agree? Yes, follow me. Because x1 equal to 2x2, this is the restriction. For these reasons, this is a S is a subset of R cube. Again, if you see that this S satisfy all the property of the axioms, or you use this tool, that is, you take any two vectors from S, that is x curve. If x curve belongs to S, then suppose it has component x1, x2, x3, and then it should be x1 equal to 2x2, and y curve be another component y1, y2, y3. These two are arbitrary because these two vectors belonging to S, this should be satisfied. So I am answering the question of Paulovi. Please know it. So these two vectors take from S, and you see that x plus lambda y curve is equal to x1 plus lambda y1 x2 plus lambda y2 x3 plus lambda y3. Now, if this belonging to S, then you check that x1 plus lambda y1, since x1 equal to 2x2 and y1 equal to 2y1, so 2 into x2 plus x2 plus lambda y2. So this since this is satisfied, this means x plus lambda y curve belonging to S. Hence, it is a subspace of V. Agree? All of you, please tell me, are you agree? It is a subspace S consisting of the element where x1 equal to 2x2 is satisfied. So the question is whether it is a subset or not. Since because this restriction, you can easily say that S is a subspace of V. For subspace, you need to prove take any two vector from S, then you check x plus lambda y curve whether belonging to S or not. If x curve plus lambda y curve belonging to S, this means S is a subspace of V. Here. Okay, thank you. So S is a subspace of V, and we already see that the basis of S is this 210001. This is the basis of S. Agree? We are lucky that this basis also orthogonal basis, because if you take scalar product of y1 curve and the y2 curve, then you see that y1 curve, y2 curve, scalar product of y1 curve, y2 curve gives 0. Hence, this is not only basis, this is the orthogonal basis. So, it is better to write the denote this vector as x1 curve, x2 curve. Where x1 curve is this and x2 curve is this. If this two vector is not orthogonal basis, then you need to convert this basis to orthogonal basis using Gram-Smith optimization. But here we are lucky that these vectors not only independent, not only generate the space, this also orthogonal to each other. Hence, this is the orthogonal basis. So I denote this x1 curve, x2 curve. So next, here, if you look at the general form, then you see that this is our beta curve. 111 is a beta curve. Now, the orthogonal basis, which I denoted by alpha, which is here n is 2, so I write it as beta curve, x1 curve, x1 curve, x1 curve into x1 curve beta curve, x2 curve x2 curl, x2 curl, x2 curl. So beta curl x1 curl, x1 is 210 and beta is 110. So beta curl x1 curl gives 3 and x1 curl 2 square plus 1, that is 5. x1 curl means 210. So you can write this as a column vector or row vector, but you should maintain the uniformity. So because of space, I just write this vector as a row vector. And I use also prime, so this is no problem. So beta curl x2 curl means x2 curl is 001 and beta is 111. So this is 1 and this is again a 1 and x2 curl is 001. So please tell me up to that. If you have any problem, please tell me. Please tell me up to that question. If you have any problem, I will discuss again. So if you simplify this 6 by 5, three by 5, 1. Okay. So this is a orthogonal projection. This is an orthogonal projection of one on S. Now beta curl is orthogonal projection of 111 on its orthocomplement. Then this is simply as 1 minus 111 minus 6 by 5, 3 by 5, 1. So this is equal to minus 1 by 5, comma 2 by 5, comma 0, prime. So this is a orthogonal projection of orthogonal 111 on this. Clear? So this is the procedure how to get orthogonal projection on subspace. If you have a vector, if you want to find the orthogonal projection, this is the procedure. Clear? Dishari. Thank you, Dishari. This is silly mistake. This should be gamma. Thank you. Thank you, Dishari. Actually, I forgot the symbol. So, thank you. This means you understand the process. So, agree? Are you okay? I changed the symbol. I write it here, gamma term. Thank you. So, next question. Suppose is and I take and it has a basis. This is the basis. This is the basis of S, and I consider, and if you take R cube, and we know the canonical basis is this, which I already discussed in my previous class. Now you see that since this thing is already appear in the basis of S, so we will construct complementary space T whose basis contain either this or this. So 1T1 is a vector which is a linear combination of 1, 0, 0, where lambda belonging to I. So lambda 0, 0, 0, lambda belonging to I. Now you can easily check that this S and T1 complementary to each other. That means S is a complementary space of T1 and T1 is a complementary space of S. Now I want to find just projection instead of orthogonal projection. I want to find projection of, now the problem is find projection of 1, 1, 1 on projection of beta term into S along T1. One thing you should remember, That is 6 by 5, 3 by 5, 1. This is also a projection. But it is not only projection, this is a orthogonal projection. But here I want to find any projection. It may not be orthogonal. Okay. So for this, I need a complementary space of S. For this, first find basis of S, which is this, and then see the canonical basis of R cube, and from this canonical basis we see that T1 should be either linear combination of this vector or this vector. Here these things are simple. If these things are not simple, you need to check one by one whether this vector can be written as a linear combination of these two vectors or not. If this vector, suppose this vector 1 0 0 written as a linear combination of these two, this means you cannot take 1 0 0 for constructing T1. If 1 0 0 cannot be written as a linear combination of these two vectors 1 to 0 0 0 1, this means you should take this vector for constructing P1. Clear or not? Tell me. Please tell me. For constructing P1, you collect those vectors from R3, basis of R3, which cannot be written as a linear combination of the basis of A. Which cannot be written as a linear combination of basis of S. Sorry, basis of S. Clear? Tell me. Okay. Only Uruniva understand this thing, or what about the other? For constructing T. Okay, Shashwati. Okay. Actually, Shashwati, see, I want to construct T1. T1 is a T1 is a complementary space of S. First, your job is find basis of S. Okay. First, you find step one is find basis of S. After getting basis of S, then you see that the basis of R cube, take every vector one by one. First, you take 1 0 0. If 1 0 0, in general, I think I illustrate this process in general. Suppose K1 consists of n vectors. These n vectors give the basis of S. Forget about R cube. I consider Rn. So S should be a subset of Rn. So that means it has a basis. The number of vectors in a basis should be less than n because it is subspace. So the orthocomplement space, so complementary space of S should be the basis of a complementary space of S, which I denoted by T1, consists of how many vectors? N minus k vectors. So now you find the vectors of a basis of T1 for the process is, first you take the canonical basis, say T1, okay, and check that whether this E1 can be written as a linear combination of x1 to xk or not. If E1 curl written as a linear combination of x1 to xk curl, this means E1 curl belonging to S. So you cannot take E1 curl as a basis, as a one of the vector of basis of T1, or T1 curl does not belong to T1. Here, similarly, if E1 again, if E1 curl does not cannot written as a linear combination of x1 curl to xk curl, this means E1 curl does not belonging to S, hence E1 curl belonging to T1. Similarly, for each EIS, you need to check this process, and using this process, you easily get E1 to E n minus k term, which gives you the basis of T1. Clear? I think you, Shashwati, clear or not? Please tell me. I'm interested only Shashwati because she raising this question. She does not understand the process. So please tell me, Shashwati, are you agreeing or not? Are you satisfied, convinced? Thank you. So now go to the particular case. So here we see that except 001, 10001, these two 100 does not belong to A. So I take 100 as a basis of T1. So T1 can be constructed as a linear combination of 100. So this thing look like that. So now beta curl, which is 111, is equal to C1 120 plus C2 001 plus C3. Just write the basis of T1. So you see that C1120 plus C2001 belonging to where? Belonging to S. Because these two are basis of S, so the linear combination of these two vectors gives a vector belonging to S. And 100 is a basis of T1, so C3 into 100 belonging to T1. And since 120001 100 is a basis of R3 and 111 is a vector in R3, so 111 should be written as a linear combination of these three vectors. Now, next thing is 5C1, C2, C3 such that left hand side equal to right hand side. So this is C1 plus C3 2C1 only C2 so this means C1 plus C3 equal to 1, 2C1 equal to 1. This means C1 equal to half, C3 equal to half using these two parts, and C2 equal to 1. So We get C1 equal to half, C3 equal to half, C2 equal to 1. So only 1. No, only 1. I think. Oh yes, you're right. Sorry. Thank you. You write only 1. If you write x1, x2, x3, then x1 is 2x2. Yes, you're right. You're right only. Thank you. 210. So just change this thing. Only when I change this thing, please. I tell everyone, please change this. This is not 120. This is 210. This is my mistake. Thank you, everyone. So 210001110. So this gives 2C1, 2C1 plus C3, and this is C1, C1, C2. This is 2C1, C3. Then C1 equal to 1. Since C1 equal to 1, C3 should be minus 1 and C2 equal to 1. Here, please tell me, are you get this solution or not? Or different solution? If so, please tell me my mistake. Are you getting this solution? Or do you get different solution? If so, then please tell me my mistake. Before going to the next step, please tell me up to that the calculation is wrong or correct. Okay. So just replace the value of C1, C2, C3 by their numerical value. That is C1 is 1, C3 is minus 1, and C2 equal to 1. So see that two one one plus minus 1 0 0. So this vector belonging to where? This vector belonging to S, and this is belonging to Q1. So I think it is, I denote by this beta curve. Listen, please tell me the notation is it beta curve, na? Beta curve. Anybody can you tell me the what is the notation of orthogonal projections? I think I give it the beta curve, or please tell me. The notation is beta curve, na? Gamma curve is orthogonal projection of S of alpha. Okay, alpha. alpha. So this 2, 1, 1 is a projection of 1, 1, 1 prime into S along T. So see that this alpha curve and this both are the realizations of 111 on where while this on S. Now which one I choose? This or this? On this I take the norm function. I denote this by y curve. Okay, norm function, and this is 111. I denote 111 by beta curve. So take norm of beta curve minus y curve. So this gives you what? So this is simply 1. Square root of this, square root of 1 is again 1, so this is 1. Now beta curve minus alpha curve equal to root over 1 minus 1 by 6 means minus 1 by 5 whole square plus 1 minus 3 by 5 is 2 by 5 whole square plus 0 square. So this is equal to what do you mean by this, Harry? Oh, gamma curve. Okay, no problem. Okay, no problem. So this is equal to, so 1 plus 4 5 by 5 square, that means 1 by 5. So 1 by root over 5 should be less than 1. So this means so this gives you the idea that the distance from beta curve, distance from alpha curve to beta curve, or difference between beta curve and alpha curve is less than difference between or distance between beta curve and y curve. So this means you have a lot of projections for beta curve, but you choose this projection 6 by 5, 3 by 5, 1, that is alpha curve orthogonal projection, because this gives you minimum distance. Minimum distance means you get more accurate result than any projection. This is the idea of least square principle. Okay, agree? So if you take another, we have another vector in this case, that is instead of 1 0 0, if you take 0 0, sorry, 0 1 0, So you write this as C1, C2, C3. So this is equal to C1 plus C3 C1 C2. Sorry, this is C3. So to C1 plus C3 equal to 1. C1 equal to 1. So this means C3 equal to minus 1. Sorry, this is C2. C1 equal to C3 and C2 equal to 1. So you get C1 equal to 1, C3 equal to minus 1, and C2 equal to 1. So I get same result. So instead of 1, 0, 0, if you take this vector and denote this by T2, then you get same projection 2, 1, 1, 1 and get the same conclusions. Generally, so I think it is C3 3 equal to 0, 1, 0. Yes, yes, yes. Sorry, again I did my mistake. No problem, Shmudit. Thank you. This means you people follow me. Okay. So please uh, find my mistake. 0, 1, 0 prime. That means 2C1 plus C3, 2C1 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 C1 plus C3. This, so 2C1 equal to 1, 2C1 equal to 1. This means C1 equal to half. C1 plus C3 equal to 1 means C3 equal to half and C2 equal to 1. So up to that, you get this thing or not? Or you get different value of C1, C2, C3. So if you get different value of C1, C2, C3, please find my mistake. First I denote, I construct another or another complementary space of T2 using 0, 1, 0 instead of 1, 0, 0. Because I already used 1, 0, 0, I denote this by complementary space by T1. This is another complementary space T2, which generated by the linear combination or constant multiply lambda into 0, 1, 0. This gives the whole space of T2. So, and can you get this thing? Can you get this calculation up to that? Please tell me. If you get different calculation, then please tell me my mistake. I'm waiting. Yes. Thank you, Shubhi. So, what about the other people? Thank you. So now replace this value of replace this one by C2 is 1 and C3 then 1 1 1 now. So now our y curl is this, which is a projection of 1 1 1 into S along T. So can you get this value or not? So now look at this value beta curve minus y curve. Then you get 1 minus 1 0, that is only 2 square, that is half 0.5. Now tell me the simplified value of 1 by root over 5. I think it is, tell me what is the uh, simplified value. After 2 decimal is okay. 1 by root over 5 is equal to what? Please tell me anybody, 1 by root over 5 equal to what? After 2 decimal place. Just anyone please tell me 1 by root over 5 is equal to what? Then I can compare with this 0.5. I think 0.5 is greater than 1 by root over 2 5. 1 by root over 1 by root over 5. Or is okay, no problem. You can check in that way also. So this is equal to 1 by root over 4. So this is again greater than 1 by root over 5. Simple. Okay. In that way you can also check. No need. No need. You can check 1 by root over 5. 4 is bigger, less than 5. So 1 by root over 4 is greater than 1 by root over 5. Again, we see that if you take another projection, in that case also, orthogonal projection is give the best result. Okay. Orthogonal projection give you the best result. So now we can conclude or claim generally that y curve, which is any projection of beta curve, should be less than equal to, sorry, should be greater than equal to beta curve minus, sorry, alpha. Alpha curve is a orthogonal projection of beta curve. Now start with beta curve minus y curve. So this is equal to this is your homework. You can easily check that beta curve minus alpha curve. This vector does not belong into. So this gives you the beta curve minus alpha curve. This gives you the gamma curve, and alpha curve minus y curve. Alpha curve uh, belonging to where? Belonging to S, and y curve also belonging to S. Okay, y curve is any projections in S, any projections of beta curve into S, and alpha curve is orthogonal projections. So both belonging to S. That means the linear combination alpha curve minus y curve is a linear combination of alpha curve and y curve. So this again belonging to S, and beta curve minus gamma curve is orthogonal to S. Hence this should be 0. So please take this thing. This is the argument. So this means so norm function always non-negative. Norm is always non-negative. So this means this implies so this result gives you, if you take the orthogonal projections instead of any projection, so orthogonal projection is it gives you the best result, because the distance between the vector beta curve, and which is unknown for you, and alpha curve, which is the orthogonal projection, this distance minimum than any other projections of beta. So this is the philosophy of least square technique which I already mentioned in my previous class. So I think these are the things, these things. Now I give some homework. Do same thing for R4. Here your beta curl equal to this. Find all complementary. Oh, sorry. I need to give you the S also. The S is equal to x1 z. So I forgot what the homework of the previous day. So please ignore this homework. Just consider this one. And even if you do this thing also, I have no problem. So this is your race. Take beta curl equal to this. Find all complementary spaces of S. Then find projection of beta curl into S along each complementary spaces. Then find orthogonal projection of beta curl and check beta curl minus y curl greater than equal beta curl minus alpha curl, where alpha curl is a orthogonal projection. I denote this by alpha curl. And projection of beta curl by y curl for all y curl, where y curl is a projection of beta curl. So here, have you any question regarding this homework? Please tell me. Before going to the next homework, please tell me, have you any doubt about this homework? If not, then if not, please tell me, then I continue. Please tell me anybody. Have you any problem? Any doubt? Okay, thank you, thank you. Next, take R5 and your S is equal to, so let's start saying. So these are all the components which I address. I think I, I think now it is clear for you, na? If you have any doubt, so tell me again. I discuss. If not, then I want to end the string. So are you satisfied? My explanation, today's explanation. Dishari, you tell me how can I find sir or orthogonal projection. Now we can find. Now you can able to find this. Tell me, or still you have a problem. Dishari, please tell me. Anybody, if you have any doubt. If not, then I want to end the stream. Okay, thank you. Thank you, Dishari. Anybody? Now you are able to find the orthogonal projection or not? Still have a doubt? Please tell me. Sornavo, yes, sir, it is clear now. Thank you, Sornavo. Dishari, yes, no more doubt. Okay, thank you. Thank you. We will meet coming Thursday. Thank you. So even I tell you, if you have any problem, don't hesitate. Call me. You know my number, or mail me or WhatsApp me. I will definitely answer your query. Thank you.